Welcome back. Hope you all have a good time to relax, and I believe that you are ready for the third session on textile and apparel testing by Dr. T. Ananthakrishnan. Now, I request our principal ma'am, Dr. Sandhya Ravi, to introduce our resource person. Over to you, ma'am.
Thank you, Shahul. It gives me immense pleasure to welcome and introduce my very own professor who taught me textile testing when I was doing my master's. Welcome you, sir, to this first 6-day virtual faculty development program. Dr. T. Ananthakrishnan graduated and got his PG and PhD in textile technology from Government SKS JTI Institute and possesses ADIM, served as a faculty in Government SKS JTI Institute for more than 33 years. He has industrial experience of 3 years and also has worked in BIET Davangere, that is Babuji Institute of Technology, as lecturer for about 2 years. Presently associated with SRSI Group of Institutions, Bengaluru, Kolar District, as an academic advisor. Sir has published 8 papers in national journals, 6 papers at the international journals, and presented various papers at the national conference. Supervised 2 doctoral candidates and guided over 50 projects for undergraduate and postgraduate programs. Sir has served as chairman and member of BOS and BOE of various universities, examined PhD candidates, and has worked as an examiner of various universities. Sir is associated and was associated with DRDO, CSTRI, and NAL as an expert committee member for evaluating projects. Associated with AICTE as an expert committee member, Sir has served as a technical expert in procurement of government department equipments, reviewer of technical papers in national and international journals, served in the Textile Association of India, Karnataka unit as honorary secretary, and chairman of conference souvenir committee held by the Karnataka unit, and also was honorary secretary of Government Sri Krishna Rajendra Silver Jubilee Technological Institute's Alumni Association, and conducted Golden and Diamond Jubilee celebrations of the same institution. Nitte School of Fashion Technology and Interior Design, in association with Bengaluru Central University, is honored to welcome Dr. T. Ananthakrishnan sir for the fifth day session for the first of its kind 6-day virtual faculty development program with the topic Textile and Apparel Testing. Now we will be starting the session with the topic Textile and Apparel Testing. Over to you, sir.
Good afternoon to all. Thank you, Dr. Sandhya Ravi, the principal of the Institute, for a very lively introduction made of me. And I also take opportunity to have my pranams to Purushottam sir, who is here, who is Guru to Guru for all, and Dr. Kari Bhai, Leela Mohan, and many of my other friends. So pleasure to be associated in this. So to begin with, the Nitte School of Fashion Technology and Interior Design with Bengaluru Central University has made a very commendable effort in having the virtual FDP of 2020 be it on fashion design and approach through creative teaching. So very, very apt at this point of time. So really, I should congratulate Dr. Sandhya Ravi and their colleagues and associates for making this. And I had also opportunity of hearing through many of the sessions over the past 5 days, and all was so interesting. And so really whether I can make you to the same level is, well, hope it should be fine. And I would be dealing on the textile and apparel testing. Innovative teaching, I don't think there can be any innovative teaching particularly to be standardized, because each one can have their own effective methods of doing that. But okay, let us see what best we ourselves can discuss about it. And I wish I would be beginning with my talk on the same. Oh, is it able? Are you able to see the my screen?
No, no, sir.
Sharing is allowed for me or no?
You can share it, sir. No problem.
Because
And everybody is seeing you.
share is not showing the thing here. Okay.
You click on you have to open it first from outside and
Hello.
full screen, not minimize. Then you
Yeah,
can see.
yeah. Yeah, full screen only. Okay, okay. Full screen.
Mr. Anand Krishna, you
Yeah, yeah.
just see on the right hand corner bottom, there is one.
Yeah. Three dots.
Present
Try
now.
to click.
In that one, there will be three options. The center one, you take it.
Okay, thank you. But here share is not highlighted.
There is present.
Right, sir.
You go for present. In that, select a window.
Yeah. That window only has been
Select
selected
the
now.
window.
Sir, there is a icon called present now.
Yeah, present now,
Yes,
and a window is there.
yes, a window.
You select that window.
In the pop-up screen, the share is not highlighted. That's what
No,
I'm
sir,
telling.
before sharing the screen, you should open up your PPT.
Okay. Fine.
You open, but
Okay.
don't minimize it.
Okay.
Open
Now
this
it is.
screen.
Now it is seen. Now it is
Yes,
seen.
it has come, sir, successful.
Okay. Thank you very much.
Okay, congratulations.
Thank you, sir.
Yeah, welcome back again. Sorry for the small glitch that was there. We are not all that technocrats to really use the computer to a very great extent, but still, okay, fine. To our view of my today's discussion would be on brief outline of textiles and apparels, need for testing, sampling, need for sample testing, and the sample testing with the type of sampling, testing conditions, fiber properties of various properties associated with fiber and yarn and fabric testings. So I had to rush through many things because of the time that it really takes to discuss on all these matters in one stroke. And also, I will not be going through the testing procedures as it would eat away the time. And anyhow, it's a procedure which has to be followed as per the standards. One has to refer the standards, recommendations that would be there, how one needs to carry out the testing. And well, therefore, I will be as far as possible to discuss on those points. Just to have a very brief outline of textiles and apparels. The term textile is a Latin word originated from the word texture, which means to weave. Textile refers to a flexible material. That is very, very important. Indeed, the most striking feature of the textile is that it's a flexible material in one direction and very rigid in the other direction, comprising of a network of natural or artificial fibers known as yarn. Then the textiles formed by weaving, knitting, crocheting, knotting, and whatnot. One's spun bonds, so many. And even if one looks at, as even in the morning, Som Sundaram was referring about the origin Rigveda period, which has referred. And even in our epics, the textiles have been referred. Egyptian history also shows the development of linen, weaving, spinning. China has practiced this agriculture from 2,000-3,000 BCs, and the recorded indication, if one looks at, then the flax and wool fabric excavations in the Swiss Lake inhabitants have been seen. And coming to the apparel, when we talk of apparels, comes from the meaning to wear, and it includes clothing and outfitting, equipment, accessories worn or carried for functions or decorations. So need for testing. What's the need for testing? So one has to look from the various angles. For example, raw material is to be characterized so that the designing of the product ultimately when one needs to process and design a product, so one should know about the characteristic material, and therefore raw material needs to be characterized. Then when it comes to the process, here I have taken some example of cotton fiber, that would be an example, and maybe a false twist texturizing here, which is a process. So even one needs to look at the process, control the process conditions, see that you get semi-materials as required for the designing of and developing a product suitably. And even the evaluation of the product as the product is made, it's a 3D woven shoe. So how it has, what is the performance that we expect from it, and whether it performs as we expect from it. So whether the characteristics, the process conditions. So it's like a feedback and feed forward data should be there. And also one has to meet the requirement of the regulating agencies. Say for example, Central Pollution Control Body, or any lot of regulating bodies are there very much, which one needs to comply with in producing a product and processing stages, and therefore one has to have those also to be met, and the requirements at all stages one need to meet. And so the data that would be acquired at the material process stages and the product, analyzing, getting the knowledge of that, then redefining the product, redefining the process stages, where it is possible to have the materials to be properly chosen, controlled. So one has to again get back the data and the knowledge back from the product. So at all stages, one need to carry out the testings. So at every stages, testing needs to be carried out. And today in the digital world, there is, online monitoring would be there, online testing would be continuously carried out, but we cannot sit back. Offline testing is equally required to see that the online process is going as it is designed. And therefore, offline testing also one need to carry out, and testing at all stages is very, very essential and vital. And to test, you require, whole population is very well. If you test it, it is fine, but it's not desirable many times, and it's not also practicable to do that. A population is a set which includes all measurement of interest that one will be carrying it out, but all population you cannot test, and therefore a sample needs to be done. And sample is a subset of the population which should truly represent, supposed to be truly representative of the population. And there are methods how best we can always see that whether it is representing, not representing, procedures are there, methods of looking at it is there. It's all well established, and developments are also taking place how best one can do about all those things. As if we have recently seen about the pandemic of this COVID and how the expectations have been made on the sound data analysis techniques, and how the real fact in many cases have a very good agreement with the postulations that was made, the expectations that was made. That is the soundness of the data analysis that has taken place now. And so one would be using all those techniques. And need for sampling, as I already told, is to have the efficiency of the time, the cost, because if you check at the population, the total population, you cannot do it where it involves cost, it involves time. Not only that, even it may lead to the erroneous result when you do it 100%. Check, not guaranteed that it is not. And in the destructive test, you cannot test all the things, because then you will not have the things with you at all to be used really. Therefore, population becomes very essential, and you need to attribute that onto the population data. So there are techniques like the non-probability samples, the probability samples, the non-probability, the process of selecting a sample from a population without using the probability theory. Whereas a probability sample is a sample that must be the representative of the population with respect to the variables of interest that would be there. And the probability sample versus non-probability samples, the representation that I will be showing you. See here, there is the bias, a lot of bias would be there here. And the various methods of sampling is there, both for non-probability and the probability sampling. Like in the probability, you have simple random sampling, cluster sampling, systematic sampling, stratified random sampling. Or here on the other side of the non-probability sampling, you have convenience sampling, judgment, or sandwich, etc., etc. And most important is the testing conditions, because when one need to test, a level ground should be there. For example, when you need to examine the students, so we should have a common question paper. You see, a student cannot be given different questions. Well, that is also, there is a method where you can assess on individual assessment can be made on a different levels. But generally speaking, so there should be a common level, common playing ground on which the fair play one can make, so that in the same way, testing conditions is to be standardized, or testing is to be carried out under testing conditions. Because many times what happens, these external agents or external factors would be affecting the parameters of the materials. And essentially, when you need to compare, so you need to do on a common ground. And particularly in the textile materials, many of them would have the response for particularly the temperature and much more for the relative humidity, or the humidity that is present around. And therefore, there is a specification with the Standard Institute says that a temperature internationally accepted is 20 degrees centigrade plus or minus 2 degrees centigrade with an RH of 65 plus or minus 4 with an ISO of 139 of 2005. And even the IS specifies, okay, depending on for local conditions and local comparisons, you can have some changes there again, etc., etc. And in the laboratory, the samples, other than the conditioning of the whole lab, is fine, but many times when it is not possible, or even in the conditioned laboratories, the conditioning chambers would always help to condition the textile materials. So textile materials is to be conditioned, brought into the equilibrium with the external responses that it is there. Inherently, it should not have something different than the external conditions or defined conditions. What it has to have intrinsically is to be, therefore one needs to condition, and time of conditioning has been specified in the standard institutions depending on the test, and as per that one needs to condition the materials, for which you will have the conditioning chambers where you can have only the humidity controlled or temperature humidity controlled, various types are all available. And most important is the testing instruments which one would be using in the quantitative test. The objective testers, many times you are using instruments. Instrumental evaluation becomes very vital. Instrument needs to be calibrated. So periodic calibrations of the instrument need to be made so that the results that you are obtaining on the instrument would be realistic and justifiable and acceptable. Therefore, you require a calibration often to be made, to be taken care of while testing the materials. So coming to the fibers, because fibers is the beginning materials for the textile processes. So though the yarn-like fibers are there very much, for example, the silk or the filamental yarn that will be produced, more or less looks like a yarn, but even those need to be modified, processed, and made into a coherent structure so that it will possess some desired yarn properties. But most of the fibers would be of the shorter lengths, not a continuous length like the filament. For example, like our hair, it would be of some short lengths, and even people who can have the long hairs, even they are all, we can call it a staple because fibers are there which are quite long enough, but still they will be stable fibers. So those fibers generally will possess properties which needs to be characterized, like the length, which is very important for the spinning process, and the twist that needs to be imparted for the cohesion that is to be built up into the fibers to make into a yarn. So that becomes important. the length is an important parameter associated with that. And the preference of these properties, though I have put it like length, fineness, strength, maturity in the case of cotton fiber only. Though in other fibers also we can talk maturity in a different sense. For example, in the wool there should be a good growth. But maturity, what we are specifying here, is associated with cotton fibers. That orders can be different depending on the process. Not that always length is very important. In certain cases, fineness may be prevalent over the length, but all those properties are equally important. Like fineness is controlling for the packing of the fibers into the yarn, and the appearance of the yarn ultimately depends on fineness. So many other properties are there, but and similarly, the strength, the performance of the product. Ultimately, so in most of the cases, would be related with the intrinsic strength of the material that it possesses. Though most of the time, strength, when we mention, it would be the tensile strength, but other than the tensile strength, there are other strengths associated with the material. So even that would also come into the picture. And similarly, there is a maturity, as I told, which is with respect to the cotton fiber. How does the cellulosic cell has grown into the cotton fiber, and the rigidity, because it is told that the textile fibers are flexible in nature, and that flexibility would be depending on the intrinsic rigidity characteristics. And for forming most of the product by using these fibers ultimately depends on the intrinsic rigidity the fiber would be possessing. For example, apparel making. In the apparel making, it's not only the monofabric that you would be using many times. Along with the monofabrics, you would be other joints you would be making in the apparel. Therefore, how it goes and mixes with them and produce the desired product ultimately, so it depends on that. So I have here only limited to the issues which is with respect to the clothing, because other than the clothing, various other uses of textiles are there. Textile is used where not, from down under the sea to the space. Therefore, in those different applications, there are other properties of the fibers which will be equally important, like the density, resiliency, softness, moisture relations. Though moisture relations is equally important in the clothing also. So it's all very much there, though the syllabus doesn't specify on those. So coming to the fiber length. So if all the fibers is having the same length, then no problem. No need to test also. Or maybe you only required to know about the one characteristic of what is the length of the fiber. But variations is inevitable. It is there in all the things of the nature, and so also in the fibers. Fibers are all not of same length. Fibers will be of different lengths. Therefore, one need to arrive at some average values. What average value? Well, it's again different issue. We may be having the mean length, we may be having the model length, we may be having the medians. Depending on the way in which you look at what characteristics or what parameter one needs to measure, well, it would do changes. For example, when one goes to the haircut, how he cuts, you see, he uses a comb and see that how he has to sort off the hairs which are of the much longer length than the comb position where he keeps it. So similarly, the same techniques are used here. There are methods like the array method. Array is you arrange the fibers according to their decreasing lengths or increasing lengths or whatever it is. And maybe direct methods, indirect methods you can use. Instead of measuring the length directly, one can measure the weight and attribute it to the length. Like if we know the body index and the body weight, you can calculate the height of the person. So in the same way, you can have some indirect means of measuring them. And there is a fibrogram method where again, not out the fibers are in, but fibers are allowed to be flow in such a way that it would simulate the conditions of the processes. In the real spinning process, how the fibers would be moving. So that would be simulated, and then that way the fibers are arranged in the fibrogram to make the measurement so that it would be more suitable when actually you need a process rather than very tediously arranging it in array methods. Or one can also measure individual fibers. Individual fibers in the sense here the sample that would be taken. Within the sample, the individual fibers can be measured, like there is an office in which optical measurement should be used to measure the fiber, and the fibers should be allowed to flow here, and each individual fibers are measured for various properties. Sensors would be there to measure them to the various properties, and the end all would be given. For example, here I have given the digital fiber graph that is used, because today most of the things what we'll be talking if is all of the digital instruments. It's like a Darshini, or I can say the diagnostic center, where you get your test results, you will also have the reference results. So something like that, even in the testings, it has become like that. You will get the actual properties, you will get the desired properties, what is the difference that you have between them. So straight away looking at the report, one can try to come at the analysis that, but doesn't mean that, so anybody can understand this that easily. Like if we look at the search engine and go for the ailments that we have, and we cannot take medicines on our own by looking at it. You see, you require a physicians, because physicians look from the various total angles, and that totality, holistic view also, the technologies can also only can make, not the digital output printout. By looking at that, one can really characterize it. And what fiber lengths one using? So fibers, you would be characterizing it and allowing it to say that whether 100 fibers or all the 100 fibers, if you catch it, what is the minimum length that you have in them. And above that, if you look at 50% of the fibers, or some 60% of the fibers, or 2.5% of the fibers, or like that, you catch only 2.5% of the 100 fibers. How much of fibers, or 2.5% of the fibers having the length and above? Let us say if you have 100 fibers and having the varying lengths from 0.5 inches to 1.5 inches, and if 2.5% of the 100 fibers, 2.5 fibers is having the fiber length of say 1.4 inches and above, then we call it as a span length and specify 1.4 as a 2.5% span length. Like that, you can various percentages span lengths can be taken, but one uses what is called as the uniformity index to know about the variability that is associated. So within certain region, what is the uniformity that is associated with the length distribution in fibers? And for that, well, we take the 50% span length, 2.5% span length, some ratio calculations you can take. So formula says that you have to calculate like that, and you arrive at some value. And the values, the table says that if it is having certain value, the character is like that. 77 and lower, we call it as very low, uniformity index is very low. If the value is 85% and above, then we can say it is higher, and above we call very high, uniformity index is very high. Like that, there is a short fiber index. How much of short fiber is there? Because the short fibers always pose problem in the processing. One thing is more the short fiber which should be removed. In the process, the cost. So when it comes to the economy, the cost of the yarn increases, and therefore one has to know about the short fiber index. Some definition would be given for the short fiber index. Well, industries can have their own definitions, or general definitions can also be followed, like anything which is below 12.7% in millimeter in case of cotton fiber is classified as short fiber, and there with the short fiber index, well, the values of 6 to 9, 10 to 3, etc. have been characterized and classified in that way. And coming to the fiber fineness, rather, which is much more important than the length, though often we begin with the length, but the fineness is very, very important properties. And in the staple fibers, there is some relationship between the fiber fineness and the length also. Some of the fibers has a direct relationship. More the finer, it will be longer in the length. For example, in the case of cotton, this is what happens. Longer the length of the cotton fiber, the fiber will be fine. Whereas in the case of the wool, it is the other way around. So in some of the fibers, it may not be all that correlated. In some fibers, it is having a good correlations. And whenever we talk of the fineness, for example, if I have a wire, then the thickness of the wire or the diameter of the wire, if the wire has got a uniform shape, then I can always have the measure the thickness of the fiber. And the thickness of the fiber or the diameter of the fiber, that should represent the fineness. So for which one can use the microscopes, or in the case of fibers, though it's not suitable for all fibers, there is a vibroscope. One can always measure the frequency for which the material vibrates across a certain harmonic length and arrive at it. There's optoelectrical methods. You can use the sensors, optical electrical sensors, where you can measure the fineness of the fiber. But when it comes to the textile fibers, all these methods is not all that suitable, because microscope measurement, first of all, it can be too tedious. So it cannot really be used, and well, even other methods are not very suitable, because fibers are not uniform in their cross section, uniform throughout their lengths. Variabilities are there, and it's also somewhat softer or compressible across. Therefore, when it is compressible, if you use even the thickness gauge, for example, it might compress the fiber. You get the different values depending on the rate at which you compress, and therefore you cannot have the reliable value of the measurement, and one has to do the indirect method. And very popular indirect method is the airflow method that is used for the textile fibers, where you pass across the fibers the air at a certain pressure. When it has to pass through, there is a resistance, therefore the pressure drops. Therefore, you can measure the drop in the pressure, or you can control the pressure drop across the fiber plug and measure the volume of the air that would be flowing across and relate it with. So it means to say there should always be some direct measurements also made. Therefore, you have to establish the relationship, you see. So then establish the relationship, like a very popular Kawabata if we talk of. There is no universal regression equation in the Kawabata systems, though it is very widely used in the garments and fabric, particularly fabric handle, characterizing the fabric handle. But well, for the set of fabrics, you will have a set of regression equations. Similarly here also. So you will have the known values. With the known values, these values you try to correlate, and if the correlation is good, then you establish some regression equation, arrive at calibrated scale. But measurement is very easy. Anybody can do. One need not scratch their head about all those equations. You just put the fiber across, put on the machine switch, and it gives out the reading. And reading can be directly read on the scale. So that's how it works. And there is again a classification. This is for the cotton fiber again, because most of the time we take cotton fiber because they're so widely used fiber. Well, and majority of product is from the cotton, and therefore, though now you have synthetics, but synthetics are all cut staples which are of more uniform lengths. You need not worry. So there is, if the fiber is too fine, for example, as it is shown here, if the fiber is too fine, then the resistance would be more for the passage of the air. So when you pass the same amount of air and with the same amount of the pressure drop, the amount of the air that comes out would be less, whereas with the coarse fiber it would be more, because it is related with the surface area. So finer the fiber, the unit surface area that it offers will be more, and therefore there will be more resistance, and therefore value should be less. Or that's how the finer fibers will have the very resistance. And we classify the fibers which has microner. With this fineness for cotton, we call it as microner value, which is a weight per length ratio, or micrograms per inch, micrograms per inch, which is, if it is 3, we call it very fine, 6 and higher, we call it very coarse, and in between. So when it comes to the fiber strength, so here again, one follows testing the bundle of fibers. Group of fibers together would be tested. So initially, since it was very difficult to have the instrumentation to find the single fiber fineness, it was not practiced. Where a group of fibers, so at least instrument has those range in which it could test, and that came as a practice. But also from the process angle, sometimes it is required. And what is known as the bundle strength is measured for the fibers, and most popular instrument for the bundle strength measurement for the stellometer, often called as strength elongation meter. So it is able to measure the strength and elongation. So there is some fiber preparing tools would be there. One has to prepare the fiber bunch. So prepared fiber bunch is to be mounted between the jaws. So here there is a jaw set where one has to mount into the jaw. So procedures has to be followed as per SOP. Standard operations procedures would be there, and one needs to very carefully follow. And after fixing, you release and the pendulum would be there, which has energy when it has to fall. So that potential energy gets converted to the energy of breaking of the fibers. Breaking of fibers requires some energy, which would be absorbed from the pendulum, and that's how it starts measuring. And the scale would be calibrated to give the strength measurement. And we use two gauges called the 0 and 3 mm gauge, so that one can measure the elongation of the fiber bundle also. And there is an elongation scale here. The small pointer to be reading the elongation of the material. And load elongation should be measured for the fiber bundle. And as you could see here, you see this is the gauge length that would be there. And when you start stretching the fiber, so at some point of break, the jaw would move to a certain other position, and whatever position to which it moves, the extra length to which it has moved from the gauge length, that would be taken as a ratio of this extra length to the original length of the fiber. You can express as percentage, you can express as ratio, whatever you want. That would be giving the elongation, and depending on that, you are again characterizing the fibers according to that. But very essential is the single fiber testing, because single fiber testing only gives a lot of characteristics. Fiber bundle doesn't give all those characteristics. It only measures the strength. Elongation, what it measures is okay. Nominal elongations we can take. It will not be a very true nature of the fiber. But whereas single fiber characterizes very well, and in the single fibers you will have the various ways in which the stress strain would be associated with the material, and at various points you can characterize the material. And we know how best it has. Where is the linearity, where is the non-linearity of the behavior of the stress and strain, etc., can also be characterized with the single fiber. But the question is only that how many fibers one need to test. So God save we have instruments where you have very high speed, which you can test them and give out the results. So with the single fiber, you can know at every point of the elongation the load that the fibers would take. So one can really work out the energy that it absorbs for the rupture, otherwise termed as the toughness that it would be there, where exactly it yields from the elastic to the non-elastic regions, etc. Ultimate breaking point, many things can be characterized. Modulus of the fibers that would be there, and how that modulus can be related to the other moduluses in various other directions would all come into the picture. So now coming to the fiber maturity. As I told, fiber maturity is the growth of the cell wall that would be there in the cotton fiber. So one can have the direct, indirect methods. So in the direct methods, under the observation of the very good microscopes, you observe the cross section of the fiber and try to measure the width of the fiber, width of the lumen, and come out with the ratios that would be there. And that ratios can be used to measure the maturity. And there are various parameters used like maturity coefficient, maturity index, percent maturity. All these things can be measured, and Again, indirect methods. Most of the testers do employ the indirect methods. So where you can use the caustic soda. Caustic soda helps in swelling so that your observation will be better. Or there is differential dyeing. The bulk of the fiber when you need to measure, you see the whole bulk can be, because the fiber dye absorptions would vary depending on the cellulose content. So there are some specific dyes where the absorption ratios would be different with the mature and immature fibers. Immature fibers and the mature fibers, they absorb in a different way, and you can have the standards of the fiber pads which would have been pre-dyed and compare against that and measure the maturity from that. So such things can be used, but where again there is a classification, maturity coefficient. You classify depending on the certain values, whether we can call it as immature fiber or a very good mature fiber, etc., etc. And other techniques are also there. Hello? Yeah? Yeah? Hello? Okay. There is other way also it can be done. That the previous slide, fineness what I was talking, the airflow instruments. Airflow instruments can be used to find the maturity. There is way in which to measure that, and often that can also be used. And the fiber rigidity, very, very difficult to measure the fiber rigidity. Complex instrumental techniques would be there, like you can have this fibers allowed to have the torque measurement. With the torque, you can try to find the flexural rigidity of the materials. Flexural rigidity is said how easily it can bend or how difficult it could be bent, and what would be the couple required to bend that, and what is the modulus that is associated. They can all be measured with the suitable pendulums that would be used, and the torque that would be developed in the material can be used. Or there is another simple method, like you can have a circular loop of the fibers, add the small weight to it, then the loop goes into an elliptical shape and the distension that it would have. So depending on the weight and the distensions, you can use the formula to arrive at the rigidity value of the fiber to a fair extent. But very important now is the concept of the high volume instrument. High volume instrument concept came through the Nsftid people. Nsftid are the leaders in measuring the textile fiber, yarn, and fabric properties, now also into the apparels. So they are, came out with the methods in which large quantities of the fibers can be measured. Therefore, you will have more realistic time, and you can have the very good control over the process, and they can be interfaced with the machine. The results can be interfaced to the machine. Today, machines are also automatic, that it would be continuously tracking the quality, no doubt, but offline testing and online readings that it will have has to be compared, and that would all be requiring in a mill. And so particularly, you see, there would be a variation. For example, from one bale to the other bale, 200 kg or 300 kg in material, you are ultimately getting the yarns of such a large volume, and your mixing should be so uniform that your yarn ultimately has to be very uniform. So to get that, then the testing of the fiber becomes very essential on a very large volume basis at a very small time. The time it takes is small, and the computerization is so much adopted there. Therefore, the results analysis would be quite fast, and a lot of analysis it can make it very effectively and bring out. I think time may run out. I need to move fast. So there again, the same properties are measured, like length, strength, etc. You have Nsftid Technologies, Premier Evolvix, Lintronics from China, Charging from China, and Statex from India, and many companies, Premier from India. All these people are there, but Nsftid is far, far ahead of all this. Then we have advanced fiber information systems, or the FIS, which is very useful for the spinning processes, where one employs what is known as the spinning consistency index would be all used there. So where, as I told earlier, aeromechanical fiber separation should be there. Here, the pin rollers helps in combing the fiber and taking out the individual fibers. And the individual fibers, you will have the sensors here, and the trash output should also be measured. Various trash segregation should be there, and so your control over the material is so good by using all these techniques. And again, high-speed microprocessor-based computing and data processing is interfaced with this to analyze the data. I just try to play here one video. Is it audible?
No, sir. Video is not open.
Not able to see?
No, no, sir.
Okay. Sorry.
Please click on the link, sir.
1 minute. 1 minute. I think there is a real problem here. I think there is a problem of that, so I would skip for a time now. I think there is a problem in that sharing. I will skip for a time and go for.
Excuse me, sir. Can we share the video?
Yeah.
Yeah, we'll share it.
Yeah, that's fine. That is fine. That would be fine.
Yeah, 2 minutes, I will share.
That's okay. That's fine. Because that is going from the browser. And it's all available in the YouTubes. Many things are available in the YouTubes. Nothing extra on that.
Profits. Have you done everything to control them? Your competition has, and they've achieved it by using the APHIS Pro 2. You see, for them, it is the essential quality control tool for optimizing all the spinning. Quality, waste, profits. Have you done everything to control them? Your competition has, and they've achieved it by using the APHIS Pro 2. You see, for them, it is the essential quality control tool for optimizing all the spinning mill preparation processes. In this way, they can produce optimal quality while controlling waste and maximizing their profits. Why have so many mills put their trust in the APHIS? It is because it has unmatched accuracy. Accurate measurements mean you can measure the same material and get the same result every time. Accurate data allows you to make precise decisions, allowing you to get your quality right, keep your waste in check, and grow your business by producing higher margin products. Each year, the superior accuracy of the APHIS is proven in global round tests made by the world-renowned cotton authority, ICA Bremen. The ICA Bremen round trials are conducted 3 times a year, involving as many as 200 textile laboratories worldwide. Each lab tests a subsample of material, the master sample being tested by ICA to compare test results from various instrument types. In this way, the Bremen-Round trials provide a regular check on the accuracy and reliability of instruments used by participants. Bremen-Round trials covering the latest Ooster APHIS Pro 2 instrument enable comparisons with the competitive product. The trials include over 50 laboratories using APHIS and about 10 using the competitive product. NEP content is the first quality parameter covered in the trials. For APHIS, the results show fairly stable variations in NEP measurement, while the competitive instrument shows high variation in data. The second parameter, short fiber content, again shows the APHIS with a lower level of variation against the competitor. The Bremen-Round trials thus provide convincing independent evidence of the superior accuracy of the APHIS versus the competitor, underlining its capability for optimum compatibility of results between different individual instruments. The eventual benefits in terms of yarn quality delivered to the customer and improved profitability for the spinner are a direct result of the process specifications and benchmarking made possible by the accuracy of the APHIS testing. With nearly 1,000 installations around the world, the APHIS Pro 2 is depended on by all the top mills in the world to maintain their competitive advantage and make the most profits from the raw material that they're using. The APHIS Pro 2 is the only fiber testing instrument that measures all the key fiber parameters as well as measures all the spinning preparation processes. This allows you to get an expert level of control of your cost by keeping all your manufacturing running consistently and predictably. To learn more about APHIS and its superior accuracy to build your competitive advantage, visit the website www.uster.com/APHIS accuracy.
Yeah, I think the presentation back. Hello?
Yes, sir. Sir, your presentation is not visible, sir.
Yeah, I am just coming to it.
Yeah, you can maximize it, sir.
From outside. Represent.
Okay, you can present. No problem.
Yes, sir. 1 second, sir. We'll do it. So you can start.
Okay, yeah. I am starting with my.
Yeah.
It's not having. Oh, upcoming. Yeah. So that is going out. Yeah, I think I have shared with you. You can make it.
Yes, sir. Sir, do it slideshow, sir.
No, the problem
There is
is
a slideshow in the top.
yeah, slideshow would be there, no doubt, but
Current setting.
yeah, there is some other issue that has come up here. I will go back to it. Oh yeah. No, it will be there. Now it is there.
Yes.
Yes, sir.
Now you could see it.
Yeah. But it's not big. It's not in slideshow, sir.
Full screen.
Do it full screen, sir.
Down, there is an icon.
Dear participant, due to some technical issues, sir has lost the connection. He'll come back in some time. Sorry for the inconvenience. Sir, can we share the PPT? Now it's proper. Sir, I think there is some issue in presenting the slide. So can we share the slides? Please unmute yourself, sir.
Please.
Yeah, sure, sir, sure. Sir. Yes, sir.
Okay.
You can start, sir. You can guide us to change the slide.
Hello?
Yes, sir. It's audible, sir. You can start.
Okay, fine. Now coming to the urine. The fibers have taken sufficient time. As usual, in the fibers is very important. It takes more time. So I would rush through the urine fabrics. So coming to the ideal urine, how an ideal urine should be there. Indeed, the urine is to be packed in such a way that when the urine is manufactured, it would be throughout the length. Same characteristics that it should possess. Whether you look at the fiber packing, whether it is the fiber arrangement that would be in the urine, it is all supposed to be very, very ideally it should be present and it should be uniform throughout. That is what an ideal urine, and that is the desire in which we are need to get the urine. But the real urine is something different. So if you look at here, so you can see a lot of variations should be there. And so a lot of deviations you can see there very much, and that is what we have to live with it. Only thing is how best to the real urine we can produce. That is very, very important. Next slide, please. So the urine properties, most important urine properties is the count or the fineness of the urine, which is expressed as a number, some ratios. Then the twist. There are various twists in the urines, like the cord and the cable twist would all be there. The twist is required for the cohesion, the hardness, the feel effect, all these things would, the twist would govern down into urine. Then the strength and elongation performance of the urine. There are other important properties like the evenness, appearance, faults, classifications, specific properties associated with the textured urine, and specific properties depending on the product that the urine would be used to be made, etc. Next slide, please. So when you come to the urine count, there is an indirect and a direct systems, as you all know, where some of the systems like the cotton count, the worsted count, the metric count, they are all indirect, which takes the ratio of some length units to the fixed weight unit. Whereas there is a direct systems where it is the opposite. It is the fixed length you would be taking, measuring its weight, and that would represent the fineness. So in the indirect, the more the number, for example, 80s is a higher number than 10s, as you see iron looks finer, whereas opposite, a 30 higher number is coarser than a coarser in a direct system. Text is also termed universal system because you can have the subunits in them. It is on par with the subunits that could be used, like you can have millitext, microtext, etc. all. Centitext. Next. So the urine count tester, as what you require is only the length and the weight. So you require a measuring unit for that. Length measuring units you require. So precise lengths can be measured, as desired lengths can also be warned, and then it can be weighed in a balance, precision balance you require to weigh it. Feed the data into the systems, you have the programs, you have the inbuilt microprocessor systems through which directly it can give the reading here itself. Many variations are there. Next. So the Oran twist, again, twist is particularly very important from the apparel point when you look at, because many of the fabric characteristics, depending on that, the twist is such thing that as you twist, the strength increases. But there is certain point after which if you start twisting, the length drops. This is for the spun yarn. In the filament yarn, this characteristics would be something different. And as I said, you have some directions, different S and Z directions. So from combinations of that, the effect, the feel of the yarns would all be different. So with the effect that would be there in the yarn, the weave, when you weave it across the warp and weft, their interactions would also make the appearance in a different way. That also affects the appearance. Next slide, please. The twist testers. So often the twist testers, one would be measuring the twist by untwisting. So twist would you have imparted, you untwist it to the zero twist. You can know how much of turns you have used for untwisting, and that can give the measurement of the twist. Or whenever you twist, it starts contracting, and therefore when you untwist, you start expanding. You twist in the opposite direction, it contracts back. Therefore, you can come back to the contract position, and you know that you are given the same amount of twist, and you can measure the twist that way. And most of the twist testers use the contraction methods. And sensors would be there to measure that again, and therefore you can have the auto readings come out. No calculations, nothing you need to make on your side, everything would come out as a result. Next. So the yarn strength and elongation, so there is again like the fiber bundle, you would be using the yarns together to test it, called the Lee. Is a skein of yarn which can be wound and skein form, and you would be testing the Lee strength, or what we call 120 yards in the case of cotton yarns. Now 100 meters are used for that, Turkey. And so after measuring the strength, you can multiply both them, called the CSP, which is a very important parameter for the quality assessment of the yarn, and also to know about the spinning efficiency. But there again, single yarn characteristic is very important. When you make the single yarn measurements, you will get a lot of information, so it would be very helpful in nature. As some typical example is given here for the polyester variations and the PLA yarn for lactic acids. Polyethylene naphthalate, which would be added to the polyester, which is a very wonderful fiber now. So how their strength characteristics and elongation characteristics are all different, it would be given out. Next slide, please. So there is again, like high volume instruments, you have a Worcester range, which would be measuring a large volumes. It can take the yarn automatically, test it at the speeds you can be varying. There will be various principles employed. But nowadays, it is all CRE or CRL, which is very important, which is used in the case of the yarns. Concentrate of elongation or concentrate of loading. Though some variations like the constant rate of traverse in the earlier machines and concentrate of braking would all be there, but important is CRE, by and large universal machines, so CRE, and the Lee testers are again used to measure the Lee or the skein of the yarn. Next slide, please. You can play the same video again. Hello?
1 minute.
1 minute, sir. We'll play the video.
Okay, fine. Is it okay or?
Sir, 2 minutes, sir.
Okay. Back to slide,
Next slide,
please.
sir.
And yeah, next slide. So I had shown my old type. Today's test or something different again. And that video was 15 minutes. Therefore, I thought I could just share some small video for the yarns. Now coming to the fabric testing. Okay, so we have in the fabric length, width, and thickness. Yeah, full. This one we can make it slideshow. So measurements of the length, width, thickness, then construction particulars for the fabric. That includes the GSM included to the construction particulars. The cofactor, which is the calculation part, the air permeability, stiffness, drape, crease, abrasion, pilling, shrinkage, bone skew in the fabric, etc. All, but much more is there along with these things in the fabrics. Again, next please. Next slide. So length and width, you have an automated this one where the length can be measured. The width also, width for the sensors you will have where you can set it, and variations of the width and width changes all can be measured with, along with the inspection for the fabric defects. It will be there, which all gets fed into, and sensors are there even to measure. Expert system is added to that. Therefore, judgment should be made on fabric defects, appearance, etc. All. Then you have digital fabric thickness gauge where so standard procedures would be there, standard specifications would be there for the base size, the anvil size, the pressure in which it has to go. All such things are pre-loaded, and therefore once you switch on, it takes care of that, and the readings it do give so. Next slide, please. So we have construction particulars in which you have to find the yarn count, the yarn threads per inch, where you can use the Beasley balance, or one can use the densimeters, which is line gratings, from which you can use it. And the crimp, where again you have the digital crimp tester, pre-tensioned yarn, and allow it to have the crimp, decrimp, and measure from the differential lengths the crimp percentages. Next. So cover is the ability the yarn would have covered into a given area of the fabric, and the pore that it will have, therefore the pore sizes, how much of yarn area it has covered. You have formulas to measure, find that, and finding the same. And you have the GSM where you can use the GSM cutters and cut the fabric according to certain sizes. Standard is 10 centimeters square, then measure the weight of that and get into the weight. GSM values. GSM is very particular, the very important parameter, classifications. As the other day, Purushottam sir was also mentioning that our Professor Muniswamy, along with the 4 classifications for the GSM, had made sub-classifications and classifications of the cofactor also in the fabric engineering process. Next, okay. Next slide, please. So air permeability is the amount of the air that can pass across the fabric, because that would be affecting a lot of our usage requirements, and therefore it is very essential. And even in certain other fabrics, filter fabrics example, that becomes very important. Therefore, measurement is required for that. There, what is done is to pass the air across the given size of the fabric, and the pressure drop is measured, or pressure drop, again as said earlier, is having from the rotometer you would be measuring how much of air it is passing through. And so for say square meter, cubic meter of the air that can pass through per minute. And again, all digital testers can take care of that. Next slide. Okay, fabric stiffness is a very, very important property. Again, that one of the methods which is used is to bend, allow the fabric to bend on its own weight to a predetermined angle. Like 41.5 is most of the time that is used. And nowadays you have the instruments where you can move the fabric at a predetermined rate, and also have the continuous tracking of the bending. Because here one of the assumption is that it bends, the unit curvature bend would be there, but the real fact is not so. the bending would be non-linear. Therefore, to have the non-linear bending characteristic understood, so you have an automated machines where you can track how exactly the shape of the fabric after it is bent, and the parameters used for bending, like bending length, flexural rigidity, bending modulus, etc. Next slide, please. The fabric drape, the ability of the fabric to gracefully hang down when it is supported over. Like when you wear the apparel, there are various places where it would have hang down over a certain support. Therefore, though it is circular shapes were taken, a lot of experiments have also gone on different shapes to bend the fabrics. But today we have even dynamic drapes measured. Auto tracking of the yarns would be there. Then here, though, the characteristic is to have the number of nodes, the nodal deviations, etc., all to use to characterize the fabric. But indeed, one of our PhD students had come out with what is concept called the volume drape. In the draped specimen, how the volume drape can be measured, and an index was developed for the same, which gives much more information about the ability for the fabric to drape out than the aerial drapes that you have here. Next. The crease tester. So crease is something where you apply the load onto a fold at a very high level or rate, we can say. But there is also a wrinkle associated with the fabric. Even for the small force applied onto the fabrics may wrinkle out. Therefore, there is both the crease and the wrinkle testers that will be carried out. The crease, you are bending the fabric along the warp, along the web separately with a predetermined load for a predetermined time, relax it out, then find out how much it recovers back. Or the wrinkle, you can sleeve of the fabric, you can turn it at a certain pressure, or weight, in other words, and then measure the wrinkle. Wrinkle is assessed rather, it is not an objective measurement. Wrinkle is assessed with the standard scales that you will have for the same. Next. So there is an abrasion. An abrasion is a high load that would be interacting with the fabric surface. You can have the fabric to fabric abrasion, or even abrasion of the non-fabric materials would be there. And the abrasion, in the abrasion resistance tester, Martindale's tester as it is popularly called, it will produce a Lissajous curve with a harmonic movement that you will have for the abrader, so that all places over the fabric to be uniformly. And the measurement would be to form a hole in the fabric, or the weight loss that would be associated with the fabric, or one can compare with the standard braided materials and rate it for the abrasion. Next slide, please. So similarly, pilling is something like a very low resistance that will be there. Even when the air passes across a fabric, some of the fibers may get pilled for the wind that would be passing across our fabric, or the skin and the fabric continuously interacting would be producing the pills onto the fabric. Therefore, well, you have a lot of other garment people, you know how you will be removing the pill with many tools. But okay, most of the time, and also it has become much more problem when you use the dissimilar fibers and blend them and produce a yarn. So you have a simulated instrument where instrument simulates the skin effect, not exactly, to a certain extent, and produce the results. Number of cycles that would be required, and then graded against the scale. Next. Shrinkage, dimensional change can be there for the water soaking, or it can also be for the thermal. Thermal interactions will also cause the change in the dimension. So dimensional changes one would be measuring. Virginal dimensions you measure. In the controlled way, you need to carry out the experiment like marking, putting the water head over it, 8 centimeter of water you are supposed to keep like that. SOP would be there, and one has to follow that and produce. In the thermal shrinkage, temperature, load, the time, etc. would all be controlled and measure the dimensional change that occurs, which would be affecting the product characteristic at the end. Next. So bone skew measurement, because due to the weaving strain, and particularly in the wet processing, the strains that would be caused onto the fabric causes the bow. Bow is the distortions of the wet yarn that would be taking, and the skew is also the linear changes in the configurations of the positioning of the yarn that would be going out, and that distance deviations would be measuring, for which one can use the templates. So standardized templates can be used and go and skew measurement or the deviations with the thread line with the true positioning that it is supposed to have. Next slide, please. Then the color fastness. So you have color fastness for laundering, rubbing, perspiration, light, clothing, sublimation, weathering, etc. all. And there again, you will have the standard scales in which you would be comparing after the color gets faded or not faded, depending on the dye characteristic, the process characteristic of the dyeing, etc. So efficiency would be different, and that you would be grading it out. And in the case of the light, you have the world standard blue that should be used. Okay, next slide, please. And today, computer color matching with the DE or delta E can also be right, but the standard method doesn't specify for that. So you have the color fastness testers like the croc meter, the lantrometer, the phadometer, the perspiration tester where you would be testing for the alkaline acidic conditions, like requiring the acidic alkaline solution, because it has to simulate our perspirations. Okay, next. Fabric strength, like the yarn fibers, the fabrics are also to be subjected for the strength along the tensile direction. So you have the various methods like the ravel strip, the cut strip, the grab or the modified grab, where you would be cutting a slit across here and finding you pull the fiber and fabric and find the strength that it needs and the elongation that it has to go out. Where you use the various parameters like the specific breaking strength, which is the strength by the GSM. Okay, next slide, please. So there is a tear resistance, rather the correct word is tear resistance. So resistance for the tearing or cutting across the fabric, the yarn across the directions from the pulling direction. So pulling direction is here, the yarn will be cut across. So that is the tearing, and various sampling preparations would be there, and tear propagations would be like that. Once the tear gets initiated, after it reaches the maximum, there would be a shearing that has to take place here, and therefore you get the curves like this. And most of the time it is the impact test that would be, because tearing often causes by the impact. Therefore impact testers are used, though this is the curve produced with the CRE machine. Okay, next. The bursting is, well, across the fiber or uniformly in all directions when you apply the load onto the fabric. So how best it can withstand that, and that is termed as the bursting. And you have the hydraulic testers, the pneumatic. Pneumatic is not commonly used, and you have the ball bursting strength called the mundane, but very popular. So the hydraulic testers that you use. So it is the bursting pressure rather that it takes for the fabric to get burst, how much pressure it withstands. Next slide, please. So this is a hydraulic bursting strength tester. This is a ball bursting strength tester, and this is a pendulum type digital tearing strength testers. Nowadays, all have come digital. Okay, next. So universal tensile testers, universal is called because you can always change the gauges and the capacities can be controlled, load cells can be changed, and the same instrumental frame can be used for many different materials. And universal strength tester it is called because it's not only performing tensile. Other than the tensile also you can do a lot like the flexural rigidity, the flexing, the tearing, etc. all can be tested in the universal tester. Even the ball bursting can be simulated onto the universal strength tester. Therefore, it has become termed as a universal strength tester. Okay, next. Garment accessories, well, you know very well about the lot of accessories that you are using onto the garment, and it requires the testing for them. Specific testers it would be needed. And next slide, please. So we have a button snap test where the button is pulled and what is the pulling force that is required for the button. Next. Impact tester onto the button where the button gets yield for the certain load on from certain length that the load would be moved across. Next. zipper tester, where it is a reciprocating or a cyclic, this one you would be carrying out on the zipping, and how many cycles that it can stand for the snapping, unsnapping, the snapping come out, snapper come out, etc. All, and zip liners, change deviations, many things it can do. Next, please. The seam strength and the seam slippage, something like a tensile only, but you are putting the seam across the material. So you make the blank test, then you make the seam across the material, then allow it to have the distortion that it takes for the seam, or the yield that it would out, or the fracture that it can occur, depending on that, the seam slippage, when the distortion starts occurring, and the seam strength. So the true curve of the fabric, the seamed curve, and the difference between these, etc., all will be used for the seam slippage. And the ultimate point where it gives out is the seam strength. Okay, next slide, please. So seam puckering, you know how the puckering occurs when you put the seam, and the standard scales are used to compare and come out with the seam puckering value. Today, there are some research which has gone through for objective measurement of the seam puckering indeed. Okay. Next slide, please. Next slide. So sewing thread, like thread diameter, it's like any other yarns. Thread is like any other yarn, but some specific properties it requires. Friction is very important. Thermal friction is very important. That is all tested for that. And knotting, looping, etc. Next. If time permits, you can play this video.
Yes, sir, we'll play the video, sir. In 2 minutes, we'll be playing the videos.
Sure, sure. That was the last slide. I think I could make it to the time almost. And hello? Hello?
Thank you, sir.
Yeah.
Yes, sir.
Yeah, that was the last slide.
Oh, thank you, sir.
Thank you very much. And
Yes,
one more slide I did not load. That list of standard IS standard numbers for the
yes,
testing of all the textile materials, which runs for 30 slides if I load. Therefore, I did not load, but one gets in. Indeed, all
yes,
these things, most of the things you do get. And
yes,
the only thing is nowadays, innovative teaching is associated that way. Rather, you find the availability of the resource is now too much. But only thing
yes,
is how best we have to find it and how best we have to use it. And so with the sound fundamental principles, understanding the sound fundamental principles, so understanding to the videos, to other materials that is there now available so easily. So it would be very wonderful to enjoy the subject. So use all those things. Thank you very much for the patient hearing all through you had. And any questions you can share with
yes,
the
sir.
chat box, or if the time is already up,
Yes,
any questions you have can be passed on to me, and I try to meet
yes, sir.
in
Yes, sir.
answering that to the best of your.
Thank you, sir, for sharing your knowledge and experience with our participants. Indeed, it was an interesting session, sir. Sir, with your permission, I would like to read out the questions raised with the participants.
Yeah.
Yes, sir. So, does the textile meets the needs of applications for which it will be used by Dr. S. Jayapriya, sir?
Indeed, very much it does. Only thing is we had to engineer. In many cases, for the specific applications, you engineer the fibers and meet the requirement. Say the field where the textile is not used, but the deviations is again too much. Failure rate is something which becomes very unpredictable in many respects. But most of the time, what happens is the intrinsic property of textiles is very high, whereas your usage time of that would be much shorter, and you would be throwing it out much before your usage. But in specific applications like technical textiles, geotextiles, or maybe medical textiles, so very stringent this one will be there and used. And you're having fibers which can really do the wonderful job now. They are being engineered and rather intelligently engineered to do the many jobs. I think I
Thank you.
have everything.
Yes, sir. Thank you, sir. Sir, they're requesting for the PPT. Sir, can we share the PPT for
Yeah,
our...
sure, absolutely. It's an open source.
Yes,
And
sir.
we can,
Yes, sir. Yes, sir. We'll sure share the PPT in the group, sir. Group participants.
thank you for helping through the session, and also I thank Dr. Sandhya Ravi for offering this opportunity for me to present through my thoughts, and thank you all, and thank you my guru Purushottam sir here and my colleague
Hello.
Kaveri
Hello, I just
Bhatt.
wanted to make one small
Yes, sir.
comment, Anand
Sure,
Krishna.
sir. Sure,
The
sir.
presentation was very good. Okay. And
Yeah,
as a quality
yeah.
man, we normally
Yeah.
test everything, and only
Yeah.
approved material we send to customers, and we get complaint from that material. So we must find out what we have to test from customer point of view, and not from the instrument manufacturer's recommendation.
Indeed, the specifications that one has to evolve for, indeed, the customer usage, the stamping on the product. When you need to sell the product, it has to meet the customer requirement.
No, that's what. No, in the customer requirement also, what I am telling, we normally test and approve, and after approving, we are sending material to customer.
Right.
After that approved material, we get complaint. Means the complaint what we receive is something which we have not tested.
Sure.
That is not there in our testing range. So we must find out what is to be tested. Every now and then we have to go on updating that one.
Yeah, that's what the feedback and feed forward of the process and the knowledge is very much required to stand. Thank you very much for your.
Anandakrishnan sir, thank you very much.
Yes,
It was indeed an excellent session. and put it across in a very simple manner. I think the picture said it all. In fact, from the sampling picture to fiber density and everything was very good. So thank you so much. I think you made it seem very simpler testing. So thank you very much for the session, sir.
Thank you, thank you. I was worried how best I can cover that whole thing and
Yeah.
this gamut because each requires. But anyhow, it was so pleasure and wonderful, and all the sessions were wonderful. And tomorrow
Thank
also,
you,
I'm
sir.
looking for a wonderful session.
Oh, thank you
Thank
so
you,
much, sir.
and
Thank you.
participants should have been greatly benefited by this.
Yes, that
Thank
is
you.
our main motto.
And equally, I am benefited at least personally
Yeah.
telling the running session. Thank you.
Yes.
Thank
Thank
you
you,
for
sir.
being with me. I
Thank you,
leave the
ma'am.
meeting.
Thank you, sir. Once again, thank you, sir, for accepting our invitation and detailing on the topic textile and apparel testing. Thank you very much, sir. A feedback form is shared in the chat box. Please fill the feedback form. It will be active only for 10 to 15 minutes. Please fill the feedback form. As morning, we had shared a feedback form of third session. We are again sharing a feedback, newly created feedback form of third session. I request participants to fill the feedback form. As we have come to the end of the FDP program, day 5, I would like to thank speaker of all the 3 sessions and the participants for spreading your valuable time with us and making the 5th day FDP a successful. And I would be happy to see you all on tomorrow's session, the last day, the 6th day of FDP program. Thank you all. Have a good day. Thank you for our resource person who spent us a lot and shared her knowledge. Thank you, sir.